So today we're going to be looking at section 7.1 part 1, which is simplifying rationals. Your essential question is, how can I find the domain of a rational expression and then simplify it? So let's start by talking about what a rational expression is. Well, a rational expression is the quotient of two polynomials. In other words, it's a polynomial divided by a polynomial. The only thing that you need to be really careful of is that the denominator can never be 0. You can't divide by 0. So let's look at a few. For example, x over y, that's a rational expression. It's a polynomial over a polynomial, or a monomial over a monomial. M plus 4 over m minus 2 is actually a rational expression. It's a polynomial over a polynomial. And they can even get so complicated that they would look similar to this. These are all polynomial expressions, or rational expressions. You're going to have to be able to find the domain of a rational expression. And if you remember from last semester, the domain is all the possible x's. And if you remember from the last slide, the only restriction that we have with rationals is you can't divide by 0. So the way that you actually find the domain, let's say for example we have this rational expression, 3 over 7x minus 14. The way that you find the domain is you actually set your denominator equal to 0 and solve. So in other words, you kind of work backwards. You say, okay, this cannot equal 0. So what number is going to make it equal 0? Because whatever number is going to make it equal 0, I can't have, because he can't be 0. So you literally just take the bottom and solve for x. So in this case, x is 2. And what that means is when x is 2, the bottom of this fraction is 0. And I can't have 0. So the way that you would write your domain is the set of all x's such that x cannot be 2. And what that tells me is x can be everything but 2, because if x is 2, the bottom of that fraction will be 0, and you can't have 0 on the bottom of a fraction. For this next part, we're going to look at simplifying rational expressions. Anytime something is written in fraction form, it can be reduced or simplified, including these polynomial expressions or rational expressions. And the way that you do it is you factor. You factor the numerator and you factor the denominator. And then you cancel any common factors. So let's say, for example, I have the polynomial expression a squared minus a minus 6 divided by a squared plus 5a plus 6. Well, the first thing I would need to do is factor my numerator and my denominator, and luckily with both of these I can use a shortcut. So if I'm looking here at the numerator, I'm looking for a number that multiplies to a negative 6 and adds to a negative 1 at the same time. So it's going to be negative 3 and positive 2. And then I'm going to look at my denominator. I'm looking for two numbers that multiply to positive 6 and add to positive 5. So that's going to be positive 3, positive 2. And then I look over here now that they're factored completely, and I just cancel any common factors from the top and the bottom. So it looks like a plus 2 and a plus 2 is going to cancel here. So I can cancel this a plus 2 and I can cancel this a plus 2. And that's going to leave me a minus 3 over a plus 3. Now be careful here. I have a lot of students that go and try to cancel these a's. You can only cancel common factors. The definition of a factor is something times something. This is something minus something. This is something plus something. I can't cancel these. If it was a times a negative 3, a times a positive 3, then we could start canceling stuff. But since these are added and subtracted, we cannot cancel them. They're not factors. And this would be your simplified answer. For this last slide, I want to talk to you about opposites. When you're talking about rational expressions, there's something called an opposite. And basically, an opposite looks something like this. An opposite is a numerator and a denominator that are flipped. So let's look at these. Notice they both have a minus sign. The only thing that's flipped is the order of the numbers. And it's like a commutative property almost with a minus sign. In rational expressions, if you happen to get opposites that look like this, they actually will cancel each other and they'll just equal a -1. How does that happen? Well, let me show you. The way that that happens is it looks something like this. If I factor out a -1 from the bottom and divide each of those by a -1, what happens is I get -3 plus m with this -1 out to the side. Well, if you look at the top and the bottom here, these are now exactly the same. Positive m, -3, -3. So it would cancel, leaving a -1. And that's where this rule comes from. In other words, it's just a shortcut. So if you notice that you have opposites, you can go ahead and cancel them. Let me show you what that's going to look like in an actual problem. Let's say I give you this rational expression and I tell you to simplify it. Well, the first thing you want to do is factor the top and the bottom. If I factor the top, I've got difference of squares, so that's r plus 4, r minus 4. I can't factor the bottom. It's not even a quadratic, so I couldn't factor if I wanted to. What I notice right here is that I have opposites. I have a positive r, a negative r, a -4, a positive r. These are opposites. They both have a minus sign. The only thing that's switched is the order of the numbers. I can actually go ahead and cancel both of those as long as I throw a -1 somewhere into the mix, leaving me a -1 and an r plus 4, and that would be my simplified answer.